Hello, my fellow mathematician and scientist. Welcome to our study. Today, we are going to consider chain rule and the trigonometric function. So, I'm going to show you step-by-step method which you can follow and obtain derivative of trigonometric function, both the trigonometric function and their inverse combined with the exponential function using chain rule and the power rule, whereby the derivative are obtained with just two simple steps and you can get your answer accurately and correctly. So welcome as we study together, whereby we simplify mathematics for you and we make it interesting so that you may continue learning this important subject. Thanks, and let us learn together. Hello, my fellow scientists. Welcome to our study today, whereby we are going to focus on chain rule, using chain rule in finding derivative. In this presentation, we are going to let d derivative with respect to x be represented by f prime or y prime. And we are going, in the first case, we want to consider it is whereby you are given the function y is equal to a function of x power n. So, applying two rules, the power rule and the chain rule, to this function, when we differentiate this function with respect to x, we are going to find that using the power rule, this n comes in front. This n comes in front of the function. Then we reduce n by 1. N is reduced by 1. So you have n minus 1. N minus 1 as indicated here. N minus 1. Then from there, what you do, you differentiate the inner function. You differentiate the inner function and you multiply by the result, f prime of x, that way. So to bring this concept at home, what I want to do is to give you a simple example. We shall do a simple example which will make this concept clear to you. Example, find the derivative of this function using power rule and the chain rule. So to do that, our index is 2. So we bring 2 in front. To differentiate that function, we simply bring 2 in front of this equation. Then we keep whatever is in the bracket constant. That is x squared plus 2x plus 1. Multiplying by 2 minus 1. Then multiplying by this function inside differentiated. So when you differentiate x squared with respect to x, we are going to get 2x. When you differentiate 2x, we are going to get 2. 1 differentiated is 0, so we multiply by that function. So that is how we can apply chain rule to get the derivative of a function like this using the power rule and the chain rule. Number 2, suppose now we are given a exponential of function x. To differentiate that, all what you need to do is to differentiate the power, the index, with respect to x this way. Then you keep the exponential the same. And good example, find derivative of function y, given that y is equal to exponential 2x. So what we are going to do, it is to differentiate 2x with respect to x. 2x with respect to x is 2, this way. Then you keep the power constant. The exponential constant, exponential 2x is kept constant. Then you multiply by the result. So this is the result, that is the derivative. Number 3 of our consideration today, it is where now you are given this another exponential. You are given y is equal to a power x, everything power n, whereby a is a constant, x is a variable. So to differentiate this using chain rule, first of all, we are going to bring n in front, that way, multiply by this function in the bracket as it is. Then we reduce the index by 1, so n minus 1. Then we multiply the result by whatever is in the bracket differentiated. For example, find the derivative of this function y is equal to bracket a power x bracket squared. So to do that, first of all, we are going to bring our n is 2, so we bring 2 in front, multiplying by our function, which is in bracket, is a power x. So a power x, then we differentiate a power x. When a power x differentiated, it will give us natural logarithm of a, and that is the result. As simple as that. Another part which we are going to consider today and right now is whereby now you are given you are given a function y is equal to natural logarithm of f of x. So to differentiate that, what we do, you differentiate the function under the bracket, which is f of x prime. You divide by whatever is in the bracket. A good example, find y prime given natural logarithm of 3x squared plus 2x plus 1, everything into bracket. So to do that, you simply differentiate this function in bracket. So 3x squared differentiated will give you 6x. Then 2x differentiated will give us 2. So this is 2, not 2x. It will give us 2. Then we divide by this function, which is so the answer is 6x plus 2, because 1 differentiated is 0, divided by, or by here the stroke means divided by 3x squared plus 2x plus 1. So that is the result. Our part 4 of our consideration today, it is chain rule and the trigonometric function. Chain rule and the trigonometric function. So the first which I'm going to consider, it is sine of function of f of x. So to differentiate this function, what you simply do is you differentiate the function in bracket, then you differentiate the sign, which is cos, and you keep the function in bracket constant. A good example is this. Given y is equal to sine of 2x, you are required to obtain y prime. So to do that, you simply differentiate 2 with respect to x. 2 differentiated with respect to x is 2. Then you differentiate sine. Sine differentiated, the derivative of sine is cos. Then you keep whatever is in the bracket constant. That is, you keep 2. We keep 2 constant here, and it is in bracket that way. Number 5, that of course of f of x. So what you do, it is the same. You differentiate whatever is in bracket. You differentiate this, which is f of x. Then you differentiate cos with respect to x, which is negative sine. That is why there is negative here, and you keep the function in bracket. Example, find y prime given y is equal to cos of 2x plus 1. So to do that, first of all, we differentiate whatever is inside the bracket. 2x plus 1 differentiated will give us 2. Cos differentiated will give us sine. So when you differentiate cos, the result is sine. Into bracket. You keep the function in the bracket, 2x plus 1. So that is how you do it in a simple way, and you are able to get it. Number 6, tan chain rule and a trigonometric function, considering now the tan. For the tangent, first of all, you differentiate the function in bracket f of x. F of x differentiated is f prime of x. When you differentiate tan, you are going to get sec f of x tan f of x. That is what you do. For example, find y prime given that y is equal to tan into brackets 2x plus natural logarithm of x. So you differentiate first of all the function inside the bracket. So you differentiate 2x plus natural logarithm of x. When we differentiate that, we are going to find that 2 differentiated will give us 2. So the result here is 2. 2, we will get 2 plus natural logarithm differentiated of x, it is 1 over x. X differentiated will give you 1. So that is why we have here 2 plus 1 over x. Then we multiply by whatever is in the bracket. Sec of 2x plus natural logarithm of x tan into brackets 2x plus natural logarithm of x. That is the result. Of course, you can see it is very simple to do it, provided you know the chain rule and the result of trigonometric function when they are differentiated. Number 5, the derivative of inverse of tangent of x, of fx. So here the result is you differentiate the function in bracket, then you divide it by 1 plus the function squared. Let us do an example so that we make it easy for you. Y is equal to tan inverse of f of x squared plus 1. So find y prime. So solution to do that, all what we need to do, it is first of all we differentiate whatever is in bracket. So when we differentiate whatever is in bracket, it is 4x squared plus 1. It will give us 8x. 1 differentiated is 0 divided by 1. This is the formula here. 1 plus bracket 4x squared plus 1. You square that bit there, that way. So that is how it is done. Number 8, it is you are told when you are given y is equal to cot inverse of f of x, you are to obtain y prime. So to obtain y prime, here we are going to have negative f of x prime divided by 1 plus bracket f of x, you square everything. And good example, find y prime given that y is equal to cot inverse of f of x. Now for those who don't know this result, I have already given the video. You can go through it and you are going to get how this result are easily obtained with ease as you become mathematician and scientist. Yeah, to get the result, we simply differentiate the function in the bracket. So x plus 1 differentiated will give us x difference plus 1 differentiated will give us 1. 1 times negative will give us negative 1 plus, so 1, this 1 here, plus bracket this function here, x plus 1 into bracket squared. So that is the result. Of course, which you can simplify to get negative 1 divided by x squared plus 2x plus 1. That is what you get after differentiating that function. So you just follow the rule. and the work becomes easier for you. So number 8, we want to see the derivative of y is equal to sec of f of x. So to do that, first of all, we are going to differentiate this function, which is in the bracket here, f of x, f prime. Then we differentiate sec. Sec, the result is sec of fx multiplied by tan of fx. Example, given y is equal to sec into bracket x squared plus 2x, find y prime. So to do that, you differentiate whatever is in the bracket here. So x squared plus 2 will give us 2x plus 2. Then sec differentiated is sec of x squared plus 2 multiplied by tan of x squared plus 2. Number 9, y is equal to sec inverse of f of x. So the result will be y prime is equal to f prime of x divided by modulus of x square root of x squared minus 1. So we do an example. Find y prime given that this can also be written as this is f. So here this is f of x, this is f of x, and this is also f of x into brackets. So when you are given y is equal to sec inverse of f of x, what you do, what you are going to do is that you are going to differentiate the function in bracket, then everything over modulus of f of x square root of f of x squared minus 1. So example, we look at example here. Find y prime given that y is equal to sec inverse of f of x. So find y prime given y is equal to sec inverse of x plus 1. So solution. So the formula is here. So what you do, you differentiate the function. So we are going to differentiate this function in bracket x plus 1, the result is 1, over this function here modulus into bracket the function is squared minus 1. And when you simplify this one, this will give you x squared plus 2x plus 1 minus 1, which will give you x squared plus 2 into bracket as shown. Number 10, y is equal to cos inverse of f of x. So to get that, y is equal to cos inverse of f of x, y prime will be given by f of x prime divided by 1 divided by square root of 1 minus f of x squared. That is f prime of x divided by square root of 1 minus f of x squared. So let us consider a simple example. Find y prime given that cos inverse of 4x plus 1. So the first thing, differentiate the function in bracket. 4x plus 1 differentiated will give us 4 divided by 1 minus square root of 1 minus this function is squared 4x plus 1 squared, which when it is simplified will give us 16x squared plus 16x squared plus height x. Here we can factor 4 outside. When we factor 4 outside, 16, we are going to be left with the 4. When we factor 4 outside, here we are going to be left with the 2. So square root of 4 is 2. Of course, if you want, you can write it here now as 2 divided by square root of 4x plus 2. So that is the derivative of course there is a negative. There is a negative there. There is a negative here from this formula because, yeah, negative 2 over that. Number 11 of our consideration today, it is when we are given y is equal to cosec of f of x. So to get the derivative of this, you are going to get negative because of cosec. Cosec differentiated give us cosec and cot. So negative, then of f of x prime, cosec f of x multiplied by cot f of x. So I'm giving you an example here. Given y is equal to cosec exponential x plus 2x, find y prime. So to begin with, first of all, you differentiate this function in bracket. Exponential differentiated will remain exponential x plus 2. 2x differentiated is 2x multiplied by cosec exponential x plus 2 multiplied by cot exponential x plus 2x. So that is the result. Very easily indeed, if you understand the concept of what is going on. What about now the derivative of cosec inverse f of x? The derivative of cosec inverse f of x. So this is found by y prime is equal to negative f of x, negative f of x, negative f of x, divided by f of x modulus, that is f of x prime negative over f of x divided by square root, divided by f of x modulus square root of f of x squared minus 1. So we consider this example here. Given cosec y is equal to cosec inverse of exponential power x, find y prime. So to do that, we differentiate exponential. We differentiate exponential x with to get the exponential x minus from the formula modulus exponential x, then we square exponential here. So exponential power x squared will give us exponential 2x, exponential 2x minus 1. So that is the result. Number 13 of our consideration, it is y is equal to sine inverse of f of x. Y prime is equal to f of x prime divided by 1 minus, so there is a minus here. So it is 1 minus f of x squared. 1 minus f of x squared. So find y prime given that y is equal to sine inverse of natural logarithm of x. So first of all, we differentiate the function. Natural logarithm of x differentiated will give us 1 over x divided by square root of 1 minus natural logarithm of x squared. Then we have our final consideration today, which is y is equal to cot of f of x. So the result is negative f of x differentiated, that is negative f prime of x cosec squared f of x. So find y prime. Yeah, negative f of x prime cosec squared f of x. So find y prime given y is equal to cot b power x. So the result is very simple. First of all, we differentiate this function. B of x differentiated is b of x natural logarithm of b into bracket cosec squared b of x. So that is the result which we obtain. So we are going to continue considering other possible cases of chain rule and trigonometric function, and combining the rules of derivative even as we continue with our learning. So much for watching this study. Kindly like, subscribe so that you won't miss any single video which I upload now and then. Also, you can make a comment there. You can suggest any area of study which you would want me to address, and I will be more than willing to tackle it on your behalf. Thanks so much for your support, guys.